Hey everyone, welcome. Yeah, welcome to kind of the first official workshop of the Polygon Hackathon hosted by Encode Club. It's going to be really cool. We've got a great dev from Polygon, Rahat over here, which is going to talk us through everything. So pretty much a quick couple of updates. If you haven't registered already, please go register for the event. It's going to be really cool. If you want to have a chat with me just about your project, about a little bit of advice, book a call on my Calendly. I've been having lots of chats with you all already. And other than that, yeah, get out there, get tweeting, get coding, and yeah, all the best for the week. Over to you, Rahat.
Hey everyone, welcome to an introduction to Web3 and Polygon. Today I'm going to be giving you kind of like a holistic view of what Web3 is, a little bit about blockchain, and why Polygon comes into the picture, and how you can kind of get started building on top of it. There will be a small element of live coding, which sometimes turns out great, sometimes doesn't, but today it's going to turn out amazing. And we're going to be, I'm going to be showing you kind of like showcasing why it's awesome to be building on Polygon versus on like a layer one solution like Ethereum. That's not to say that you shouldn't, but we're going to be talking about some of those reasons in a bit. First of all, who am I? My name is Rahat. I'm a developer advocate over at Polygon. What does that mean? I get to do cool stuff like this where I come talk to you folks, teach you a little bit about Polygon, how to build on top of it. And yeah, I've previously been a front-end engineer in my past life, also a freelance Solidity engineer. Overall, just like an indie hacker / Web3 enthusiast. And these are some places you can find me. Any code that I go through during this presentation, I will post up on my GitHub afterwards. So that's /Rahat-ch for GitHub. So you can find all of that there. First of all, what is Web3? Like, probably should start there, right? It's a very loaded concept, and there are different parts of it. I took this from like my research kind of like online in ways that I can kind of like, I saw other people explaining like the phases of the internet. So many people refer to like Web 1, I guess for lack of a better term, is like the read-only web, right? You know, we were able to like put up some HTML pages. People can go on and read, you know, some articles, read some news, and there's not a lot of interaction going on there, right? You just kind of have information, you can share it, you can read it, and that's it. Web 2 was kind of like introduced with like this read and write capabilities. You know, their interactions began. You could create profiles on like social media, on Twitter, Facebook. But the problem is like the data here is owned by those companies that provide these interactions. You know, if you're on Twitter, you're tweeting about whatever hot take that you have on Web3 or anything else, you know, that tweet is still not really your content. It's owned by Twitter. It can be taken off by Twitter. It can be censored by Twitter. It can, you know, it's not really under your control at that point. So then we come into this concept of Web3, which is internet for the individuals. You know, it's supported by blockchain technologies, having native payments and data owned by the user. So what do those three things kind of mean, right? You know, supported by blockchain technologies, we're going to go into in just a little bit. Native payments, meaning like, you know, especially if you're building in like the EVM side of things, which is where we're going to be talking about, is just like being able to like have, you know, income kind of streamed natively through the code to somebody so they can like actually earn and just like have ownership over, you know, their content, earn from it without having an intermediary, without having like this other whole application that, you know, kind of owns that and provides that to them. And the data itself is owned by the user thanks to things like wallets, thanks to just this ability of having these like key value pairs of public and private keys for pointing to different types of data on the blockchain. What is Web3 to me? That's like the overall kind of like view, right? Of like what the technologies are and how we're looking at it. But I honestly see Web3 as like really a way for creatives to be able to build out a sustainable income, for us to be able to empower individuals to actually own their data, to actually have, you know, rights to their own information and the ability for them to decide who uses it for what purpose, etc. And these, we're not there yet in Web3. Whoever tells you we're already there, if we were already there, this hackathon wouldn't exist. You know, that's why we're here. That's why we're learning about these technologies, so that I can give you some of the primitives so that you can go out and like build these things. So going back to the blockchain part. So we're going to start from the fundamentals a little bit and build up from there. So what is a blockchain? So blockchain is a distributed database shared among nodes on a network. Nodes are just fancy terms for computers. There's just computers all over the world that host this gigantic database. They share it, and you can see different, like there are different copies of it all over, and a holistic kind of like snapshot view of all of those nodes gives you this database, which is the blockchain. This is just like complex data that are linked by cryptographical puzzles. In order for us to be able to read these, the underlying technology uses different cryptographical hashes to, either make that data private or make that data kind of like accessible via, wallets and things like that. Consensus stops us from changing history because we have this distributed database, because we have, my computer, your computer, other computers kind of running versions or like actual copies of this database. We can take a holistic consensus view of like what this looks like, of what the data currently is. And if we look at the overall consensus of like what most people have as like the source of truth for the blockchain, we come to a point where, you can't go in and change or completely overturn like the historical data of some of this blockchain, of the data on the blockchain. And I've got a little bit of a demo here for you before we hop into some code of like what that kind of looks like. This is an awesome website for just getting a demo of like a visual representation of what a blockchain is. This is andersonbrownsworth.com/blockchain. And we're going to start from like the smallest thing, a hash, just like a piece of data. So this piece of data, I can't spell my own name. So my name is represented by this alphanumeric hash right here, value, right? I can do something like change the capitalization of my name, the entire hash changes, right? So add a space, the entire hash changes. So all of your values are cryptographically hashed into this hash value, right? That is the smallest piece of the puzzle for a blockchain. So now we go next level up. We look at a block. So what is a block? So block has, so this is again a very like simplified version. This will not give you like 100% what is on the blockchain, but just give you like a high level overview. But blocks will have numbers. They'll also have this thing called a nonce, which is called a number used once. And generally, when you're looking at a blockchain, the point is that a miner or someone who is like validating this transaction has to run a bunch of calculations to figure out what this nonce is. So this is the nonce that would appear for this blockchain if the block was at number 1 and if there was no data. And then this is the hash associated to that value. Now, it's green right now. If I add in my name, it turns red. Why does it turn red? Because I updated this data to have my name in it, and the hash updated as well. This hash, this data, and this block number, once you've gone through these different cryptographical values, do not add up to this nonce. So we have to mine it. Hit mine, and you'll see that the nonce was updated. This is the nonce that is associated with this hash, my name, and the block number. So now let's get a bunch of blocks together, the actual blockchain, right? So now I've got a bunch of these blocks, and you'll see an additional piece of information that we have is this previous value. Previous value of blockchain 1 is 0 because there's nothing before it, but everything else has this previous value in it, in addition to the hash and the nonce and the block. So let me do something like, again, adding my name in here. Not only does my block turn red, every single other block in the blockchain after it turns red. The why? Because I have to remine this to get new values for the nonce. But then I have to get new values for this previous value, right? So I have to now go in, remine everything else to get a previous value that actually goes and matches back to the block that came before it. And that's where this like concept of like not being able to change history comes into play. Because if I change, even if I add a space in that first value, right? Once again, I have to go in, mine everything to actually have it, to basically rewrite history, you know? And this is one of the most powerful pieces of the blockchain where, you know, every block on the blockchain has a reference to what came before it. So changing something at any point in time requires you to change everything that came after it. Then we get into this distributed part. You might say like, hey, someone could just go into the blockchain and just go in and mine every single thing, every single block afterwards, right? Then we'd have, you know, the whole consensus, the whole history changed eventually. Well, that's where the distributed kind of like ledger technology comes in of like, yes, I might be peer A, I might be doing something fraudulent, like adding data on the first blockchain and then going and remining everything else. But there's also peer B, there's also peer C, etc. And we can go on from there, who have different data than I do. They don't have my name on block one. And then we look at like consensus. Peer A has this data, but both peer B and peer C do not have this data. The consensus says that peer B and peer C are correct because a larger amount of the distributed system says that my name does not exist on block one. Again, this is a very rudimentary sort of take on this, but just that kind of like gives you an idea of like why blockchain in general is so powerful, because this distributed technology, there is no one point of failure. The peer A might have gotten hacked, might have like had some fraudulent activity going on with it, but because we have peer B, C, D, E, F, G, whatever, we now have a consensus for what the actual source of truth is. So that is a little bit of the demo that I like to go through for these. But now a brief history lesson. So in about January of 2009, Bitcoin was created by someone called Satoshi Nakamoto. We don't know who this person is. Maybe they're a group of people, maybe it's me, I don't know. But they created Bitcoin, and out came like this Bitcoin white paper that you can read. I definitely recommend looking into it if you just want like a good understanding of some of like the whys the technology came about and how it came about. Really, it's a dense read, but it's definitely worth it. So that was about 2009, kind of like was more for like the financial side of things, for creating that ability to have that decentralized finance, or like the beginnings of it. July 2015, Ethereum was created by Vitalik Buterin. Ethereum now became this thing where it's not just about money. You can create entire applications on the blockchain, have all of these different pieces of data saved to it. And that is done through the form of smart contracts. And we're going to be looking at smart contracts in a bit. But smart contracts, and as well as like the Ethereum or EVM, Ethereum virtual machine, have been going through ongoing improvements since it was created till the present, in the form of like different standards. And these standards are usually accessible through a place called Open Zeppelin, which we'll also be exploring in a bit, where you can actually like import contracts that follow a specific standard for how you should write things. For example, the thing that I'm going to be live coding out today is going to be a very small implementation of an ERC20 token. What does ERC20 mean? ERC20 is just a standard for how you should write your own token, for how you should build your next Dogecoin or your next Shiba coin or whatever. And essentially what that means is, you already have the functionality for like minting some coins. You already have the functionality for transferring, for keeping track of how many are in circulation, etc. Because those are like little things that we don't want to keep reinventing, keep writing over and over and over and over again. That's where these like improvements and proposals came in from, and we'll explore that in a second. But there's kind of an issue with using a layer one solution like Ethereum. When you're using Ethereum, if you recall back to like the mining that goes on, that mining has to be done by several peers on this network, right? Miners need incentives in order to actually, do this for us. For otherwise, why would they, use all their computing power to actually help us keep this system up? And that comes associated with what are called gas fees or transaction fees to actually run all of this stuff. So in response to that, in about October of 2017, Polygon was launched. And Polygon was formerly known at that time as Matic Network. Matic is actually the native token that is used on the Polygon network. So what is Polygon? So Polygon, we are the leading platform for Ethereum scaling and infrastructure development. We provide different solutions, L2 solutions like ZK rollups, optimistic rollups, provide side chains, and different solutions that are kind of like, what is your use case? Here's a solution for it, because there is no one size fits all, even in Web3 and the blockchain sense either. Today, we're really going to be focusing on the proof of stake blockchain, which is our most popular solution. And if you've kind of already been like diving into the Web3 side of things, this is probably what you would be most familiar with. The proof of stake blockchain that we have is EVM compatible. What does that mean? If you've already been developing on top of Ethereum, if you've already been kind of launching your own smart projects using Solidity, using any of the tools in the Ethereum ecosystem, you do not have to learn anything new. All you have to do is change one line of code and you are good to go for like developing on Polygon. There's nothing new to learn in that sense. So we kept the developer experience from the EVM world intact. The other thing I mentioned before, our native token is Matic. So rather than kind of like seeing fees in like ETH, you would see it in Matic. And then these two things where I'm going to be showing you a little bit more and explaining more are that it's accessible and sustainable. So I'm going to come back to those 2 points in just a bit. But first of all, why should you build on the proof of stake blockchain? Why should you build on Polygon? Speed is one thing. 65,000 transactions per second, pretty quickly. Like things are much faster than on like a layer one solution like Ethereum. But at the same time, you can still leverage Ethereum. You can still leverage Ethereum as like your final kind of like layer of truth, right? You can conduct all of your transactions on the Polygon blockchain, maybe mint NFTs, mint tokens, whatever. And then you can bridge those assets back over to Ethereum. So you can still leverage the security and power of Ethereum while building on top of Polygon. And then one of the main things is like you save on costs. Approximately 10,000 times lower costs per transaction than Ethereum. That's why you might want to do some of your heavy calculations, some of your heavy kind of transactional things on top of Polygon, and then supercharge your UX to eventually have things settled on Ethereum. So I want to talk a little bit about why it's accessible. To do that, we're going to do some live coding. So here I have what's called the Remix Ethereum IDE, which is an online platform for essentially writing out your own smart contracts and quickly kind of deploying them. It's really good for testing things out. Even for like most projects, you can probably get away with like building out your smart contract and deploying it through Remix. Once you get to like more complex stuff, you might want to have your own like set of tools, which we'll also kind of touch on in a little bit. But I'm going to copy and paste just these 2 lines of code for now. First line just kind of says that the license for this code is MIT, anyone can use it. And then I'm just declaring which version of Solidity I'm using. Next, I'm going to import from OpenZeppelin. So I mentioned OpenZeppelin as having all these different standards for how we should go about and like build certain things. So here I'm importing the OpenZeppelin standard for building an ERC20 token. So if you wanted to build your own coin, your own token on top of the Polygon network, this is sort of like the most basic implementation of that. So I'm just going to declare that this contract, we're going to call it, I don't know, Rahat coin. And we're going to say that it is an ERC20. All right. So we've got our contract. Rahat coin is inheriting from the ERC20 contract, meaning I now have access to all of the functionality of ERC20. And what I'm going to do now is I'm going to create an initial supply for my coin. I'm just going to give it like 1,000. And when I do that, I have to multiply by this value of 10 to the 18th power. Why am I doing that? So, okay, it's still going black. Okay, all right. So why am I multiplying by 10 to the 18th power? 10 to the 18th power, that represents the smallest denomination of like Ether, Matic, or whatever coin called Wei. And when you are building out your smart contract, when you're writing Solidity code, most of like your calculations are going to be done in Wei. So this entire 10 to the 18th power number is equal to like 1 ETH, 1 Matic, 1 coin, etc. So 1,000 times this 10 to the 18th power will give me 1,000 of my coins. So that's my initial supply. Now I'm going to have this constructor. Let me remember to add that in there. Okay, constructor. So the constructor can take some arguments for like when you first deploy your smart contract. In our case, what we're going to do is that in our constructor, we're just going to declare that we're building out this ERC20 token. So the ERC20 standard has a constructor that takes in 2 values. The first value is going to be the name of your coin. So string that says Rahat coin, and then the symbol for your coin, which I'll just say is RC. You can find this in the OpenZeppelin documentation of like how to create an instance of your own ERC20 token. Inside of the constructor, we're just going to right away mint, and I get this underscore mint function again from the ERC20 standard, which I have access to because Rahat coin is now an ERC20 token. So the ERC20 standard is going to take a message.sender. Message.sender refers to who is this person who is currently interacting with this contract. In the case of like being inside of this constructor runs on the actual deployment of the contract. So it's going to be whoever's deploying it. So we're going to supply that address as well as the number for the supply. So that is just going to mint 1,000 Rahat coins onto the blockchain. So this is pretty much all you need to create your own coin, to create your own token. In an actual real world implementation, you might do things like maybe adding things like yield to your coin, adding some type of additional functionality. And you can do that past the constructor, adding like additional functionality for it. But just for the sake of having a token that can be deployed onto the blockchain, this is kind of all you need. Again, in real life, you might also want to have like varying ways of like increasing the supply, decreasing supply, burning. That can all be added here as well. Cool. So I'm just going to make sure. All right, so I am on the Polygon mainnet. I'm going to switch first to the Ethereum mainnet. And we're going to see how much it costs for us to deploy this onto the Ethereum mainnet. I'm not actually going to deploy it, but in Remix, I can go to this little button here, hit compile. Looks like I am missing something. I am missing a semicolon. There we go. Semicolons and commas will always ruin the live coding experience, but we're good to go. As long as you have this green check mark, that means everything compiled correctly. So now I'm going to see what happens when I try to deploy this. If I just make sure I'm on the Rahat coin contract and hit deploy. Oh, whoops. So you have to actually change your environment inside of here. So I was just on this like virtual JavaScript environment, which is like sort of like a local fake blockchain instance for you to like quickly test things out. I'm going to change to injected Web3. Injected Web3 just means it's going to like connect to my MetaMask. So I hit deploy. That's fine. Cool. Confirm. All right. So wow. When I was testing this last night, the gas fee was like $30. Right now it is $103.48 if I wanted to deploy this like 5 lines of code onto the Ethereum mainnet, right? And the thing to kind of went down a little bit. But the thing to kind of remember is like the more complex smart contract that you have, the more lines of code, the more logic that you add to your smart contract, you're gonna have to pay more gas, right? And I remember like when I was first learning about how to build my own smart contract about summer of last year, I tried to put one out onto mainnet. It was very terribly written code. There was a lot of nonsense going on, but I just wanted to try it out. And it was happening at the same time as several very large NFT drops. And I think if I were to go ahead and do that, it would, I think my bill would have come up to like $1,000-something, which for an indie developer, an indie hacker, it's not sustainable, right? It prices out a lot of people from like being able to deploy something onto a mainnet. Let's switch this now to the Polygon mainnet. Awesome. So I've gone ahead in my MetaMask. I've switched over to the Polygon mainnet. And if I hit deploy now, oh no. Okay. So now it says that if I were to actually deploy this, it would cost me about 0.05 Matic. One Matic right now, I think is about like 60 cents or something. So this is like a fraction of a penny. It went from $100 to a fraction of a penny. And that's kind of like showcase like why we make things a little bit more accessible, like how much cheaper it is to actually deploy your contracts out onto a mainnet using Polygon. So not only are transactions a lot faster, you leverage the ability to get things onto a mainnet, to get things into a production environment at a fraction of the cost, while still, again, being able to have that choice of eventually putting your stuff, bridging things over to Ethereum, which will cost money, yes, but you can kind of like come down to that road once you have like a working application. Cool. So that's a little bit about the accessible part. I will have like another workshop later this week where we're going to dive like further into the code. We're going to like build out our own, NFT minting smart contract. And during that one, we'll like look at things like a little bit of like some of the other tools, some of those which I'll mention in just a bit. But yes, let's go to the next point, sustainable. So recently, we've committed to being a sustainable blockchain. We believe it's important that as we're building for the future of the world, that we actually take care of the world as we do it. We've committed to being to offsetting all of our carbon emissions from like the beginning of when Polygon was created, and the actual sort of goal for us is to be like completely carbon negative. So once we're done kind of like offsetting the carbon that we've kind of like put out into the world, we're trying to become one of the very first blockchains to be completely carbon negative and completely climate friendly. So that is one of like the bigger sort of pushbacks that a lot of folks who are against Web3 kind of give. So this is an option for building in Web3 where you can still kind of like keep energy costs very, very, very low and work on a green sort of blockchain where we're constantly working on making sure that our carbon footprint is as low as possible. So how do you start building? What are some of the tools that you need? What are some of the things that would be useful for you to start diving into to get started on your Web3 journey? First thing we're going to look at is wallet setup. So when I went through that bit of code, I showed you in my MetaMask how I switched between the Ethereum network as well as the Polygon network. If you don't have that set up, this is how you would get that set up. We're going to go to polygonscan.com. If you've already been building on Ethereum, this probably would look very familiar to Etherscan. This is where you can like look at different transactions that are happening. If you mint an NFT, you can like verify it here. If you send someone some funds, you can verify all that here. Any transaction that takes place on Polygon is available here. When you go to polygonscan.com, bump this up, you scroll down all the way to the bottom. There's a little button here that says Add Polygon Network. If you click that, it'll open up your MetaMask and allow you to, it'll just automatically add the network for you. I've already got it, so I've got this pop-up that says it's already been added. If you don't have it yet, MetaMask will open up and just like verify that you want to add the Polygon network. So that's for adding the mainnet, but we don't always want to develop on mainnet. You know, you want to do things on a testnet first. So our testnet, to get over there, instead of polygonscan.com, you go to mumbai.polygonscan.com. That's the name of our testnet, and works very much the same way. Rather than looking at like real world transactions, you'll look at different test transactions here. And it works the same way. If you scroll down and go all the way to the bottom, you can add the Mumbai network. Oh, I didn't have it. Okay. Okay, I do have it. All right, yeah. And the Mumbai network will allow you to do, when you connect to the Mumbai network, you can do test transactions without having to use like real money. So now that we have the Mumbai Polygon scan, the Mumbai network added to MetaMask, we can go to the Polygon faucet, which is at faucet.polygon.technology. And here you can request to receive your own Matic. These are test Matic, can't use it for like real transactions. This is only for like the Mumbai network for test transactions, but pretty simple. As long as you're on the Polygon test network, you just copy your account, your wallet address, paste it in here, and you select what token you want. We'll just stick to the Matic token because that's where you'll probably be using the most anyway. You hit submit, and I think you'll receive anywhere from like 0.2 to 0.5 Matic within like 5 to 10 minutes. But we're not going to stay around for that. But as long as you do that, you'll be kind of like set up to start building. Have yourself like already connected to the right networks and getting the test funds that you would need to start building. Next up, what are some languages that would be helpful to know when you're building a Polygon? Important language would probably be Solidity. It's important for pretty much all EVM based blockchains, meaning which is short for Ethereum virtual machine, anything that is compatible with the EVM network. Solidity is how we write all of our smart contracts. That was the language I was showcasing before. Some other languages that are pretty helpful to know would be JavaScript or Python. A lot of the tools in the EVM ecosystem are written in JavaScript, so knowing JavaScript is very advantageous. Some tools like Rahat, which is a environment for like building and testing your environments for your smart contracts, are done in JavaScript. There are other tools like Brownie, etc., which are done in Python. So either or, kind of like choose which one you want. You don't have to learn all of these things. You just kind of like pick the things that are useful for your journey. Maybe on your team, you're building out the smart contract. So knowing Solidity is probably the most important thing for you. Maybe a little bit of JavaScript for the tooling if you decide to use something like Rahat. And folks who are on the front end probably need to be more well-versed in something like JavaScript. If you have like a server or something kind of going on there, Python. But you don't need to know everything to become a developer in this space. So I mentioned some tools already, and we looked at Remix, but just to give you an idea of some of the other tools that will help you in creating these smart contracts are just like decentralized applications. One I mentioned before was Hardhat. So Hardhat is a development environment for writing, testing, and deploying smart contracts. We're going to do a deeper dive into Hardhat on my next workshop, but basically, it is a JavaScript-based tool that will help you scaffold out like some boilerplate code for how you should write your smart contracts, help you with writing scripts to actually deploy them onto the blockchain and for testing, etc. Some alternatives to Hardhat include I think Truffle, Brownie if you're more in like the Python space. But I don't personally think any of these tools are better than the other. It really depends on like what works for you, what works for your team. I use Hardhat because I enjoy their documentation, but you can do the same sort of things with things like Truffle or Brownie. The other thing, the Remix IDE, which I showcased earlier while we were doing that little small live coding thing. That's an online IDE for writing and deploying smart contracts in your browser. So if you don't want to like go through and create, use Hardhat to like create an environment locally, Remix can make it a lot easier to just focus on the smart contracts, just focus on Solidity, and let Remix kind of handle everything else of like putting everything on the blockchain, putting everything into a mainnet or a test net, whatever it is, without you having to worry about the scripts and everything like that. And it's good for like proof of concepts, smart contracts to like get something shipped and out the door. But as you kind of like go into like more complex use cases, something like Hardhat would probably be a better choice. And lastly, I wanted to shout out specific like tools on the front end. One thing that the Web3 space I wish focused on a little bit more is like good UIs, good user experiences. Some tools that'll help you on that end are things like Ethers.js, Web3.js. So Ethers and Web3.js are packages for connecting your front end to the blockchain, for actually like reading and interacting with your smart contracts, etc. One really good library that came in after that is the WAGMI library. This was created by someone from the Mirror team. The WAGMI library is built around Ethers.js. The first version of it gave you a bunch of like,
can I ask you a question real quick? Is that okay?
Yeah.
So, what are we talking about? I'm sorry, I just joined.
Oh,
hey Johnny, we're gonna wait for questions till the end, so please.
Oh, I'm so sorry.
Perfect, no worries. Over to Rahat.
Okay, I love you.
All right. Yeah. So, you know, the WAGMI library, the first version of it was like specifically for building front ends in React. React is probably the most popular front end tool in the Web3 space, front end library for building out your UIs. But newer versions of it are front end agnostic, meaning that you can use whatever front end that you want. So, you know, using the WAGMI tool is something that will probably be helpful for like kind of like quickly building, doing things like interacting with your smart contract that would take a little bit extra time and more code to write out using like Ethers or Web3.js. Some things that I haven't written down on here that have very recently came out. Things are coming out all the time. But Rainbow UI Kit is a really awesome tool for like connecting to like all different types of wallets. It's one that essentially, like with a little bit of configuration, you connect to like not only like MetaMask wallets that are in your browser, but also like mobile wallets and hardware wallets. It's important to like try to make sure that when you're building to, you know, make your dApp as accessible as possible for different types of users. So one thing I wanted to also shout out is like the Polygon Academy. Some of the things that I spoke about today are available for you to do a deeper dive into on the Polygon Academy. So that's on academy.polygon.technology. We're constantly making updates to that, so you might see like different versions of things coming out very soon. And we're excited about some of the work we're doing on that end. But yeah, again, just to give you guys a little bit idea of who I am, developer advocate at Polygon. These are places you can find me. I'm always open for like questions. If you want more resources for like different things that you can dive into and learn, I'm happy to answer those as well. But yeah, I would love to open it up to questions for everyone now. I know I threw out a bunch of information at you, but wanted to give you just that high level view. What is Web3? What is Polygon? Before we dive into like a bunch of more coding in the next workshop.
Great stuff. Thank you so much. There are a couple of questions that I might just scroll through, and then we'll hand over to the floor to ask a couple of questions. Someone asked if every transaction needs gas fees, how if we have zero gas? I presume you just need to go on testnet if I'm correct there.
Yeah, so you can't really have zero, like completely zero gas fees on any transactions, because like you need that network of like miners or validators to like help you with like the distributed network to like actually keep the blockchain kind of running in a decentralized manner. There are like more complex, I guess, things you can do where and I'll just like touch on it. I won't go too deep into it. This is a whole big other rabbit hole, something called like gasless meta transactions, where you actually cover the gas fee for the user. And that might be something you might want to do for like new users to like introduce them to your DApp and essentially like onboard new users onto like your Web3 platform. Take a look at some of these other ones. Rainbow, yeah. So it's a Rainbow UI kit. It's a UI kit for building out building out like a wallet connect feature. If you want to connect to different types of wallet. Where can I learn Solidity? A couple different places. I learned through things like Crypto Zombies. So Crypto Zombies is a cool way of learning where you just like, it's like a gamified approach to it where you're like building a zombie factory, but you're using like Solidity to do it. So it's like got these like little cute animations and things, but it teaches you like a bunch of concepts in Solidity. So if you wanted to just get like that really like base level of Solidity and just like understand it, that's a good place. There's another one called Solidity by Example. Let me actually grab some of these links. I'll put them into the chat. Solidity by Example is one. It'll give you like a list of different functionality and things that you can try out. As well as Crypto Zombies. So this is like for if you want like that base, how do I code in Solidity type of tutorial. Okay. Let's see. Next question. Is attending a hackathon without much knowledge okay? I mean, yeah, hackathons can be a great learning experience, you know. I used to go to hackathons a lot, just like learn from other folks. Like I may not have had, you know, a lot of experience building out smart contracts myself, but I was able to like use some of my other, you know, skills to like help out the team and then pick up on like building in smart contracts and things like that. So I think hackathons are really awesome things to do if you want to learn. Rainbow, okay. Mr. Twitter. My Twitter is @Rahat Codes. I'll drop a link here as well.
Have we got any questions about Polygon itself? We are going to dive quite a bit deeper this week and next week. So any kind of questions about how to get into crypto jobs, you can just ping me on Discord and I'll answer that all for you.
Yeah, someone asked like why we need the Polygon faucet Awesome question. So when you're building on like a test network, if you're building on a real network, you need some tokens, right? You need some Matic to do your transactions, to test things out, to interact with the blockchain. On a test network, you don't have to use real money to do so. You can go onto the Polygon faucet to just request a like small amount of tokens on the test network, specifically for the purpose of like interacting with the blockchain there. Okay, thanks. I'm curious if Polygon has a lag due to the way rollups kind of bunch transactions together. So there isn't really a lag because like the first sort of thing that happens when you're using the Polygon network is like the Polygon blockchain is where your transactions will first occur. And then if you're eventually bridging to Ethereum, you can do so of like, putting things like specifically saying like, I want to put something onto the Ethereum network, and there's a whole process for that. But if you're, I guess maybe in rollups, in rollups again, there's still like some stuff happening on like the base sort of chain that you're working on, that are eventually rolled up to Ethereum. The way that it works right now on the Polygon network is like we have what are called checkpoints. So during each of those checkpoints, you're almost like saving data to. It's like if you think about it, and like in terms of a game, you're like saving some state that can be referred to on the Ethereum network. That's done through what's called like our plasma chain. So that's a whole like deeper level of stuff there that might take a whole other presentation to explain. But things happen on the Polygon blockchain. Things are saved by this plasma layer and referred to on the Ethereum network. Is kind of like the very high level way of looking at it. Is there a way to bundle up microtransactions on Polygon to optimize on gas fees? So yeah, I mean, you can just like conduct all of your transactions straight on the Polygon blockchain, and like all of your heavy compute can just be done there. And then what you can look at is just like whatever the final outcome of those transactions are can be put onto Ethereum. So let's say I'm minting an NFT, right? If I'm minting an NFT, I can have that transaction just occur on Polygon. Everything is done. The minting is done. All of the metadata for the NFT exists. And then at the end, if I want, I can take a bunch of like NFTs and bridge them over to Ethereum. But all of the heavy compute is done on Polygon. So you kind of like don't have to worry about the gas fees being too high in that case. Does Polygon connect with other Ethereum-based networks? I'm pretty sure you can like look up different bridges, that can transfer from different EVM networks. The main one that I'm most familiar with is like the Polygon to Ethereum network. That's the one that we have support for on like our official site. Is Polygon essentially trying to be the Lightning Network, but for ETH? I guess Lightning Network in terms of like the Bitcoin stuff going on. I guess you could kind of look at it that way. Polygon definitely is aiming to be sort of like the scaling solution for building on top of Ethereum. So, everything, like we still believe like, Ethereum is going to be the base layer. Ethereum is going to be where like your final source of truth is. But to make things, more accessible and more easily usable by, the masses and like different types of folks, we want to create a way to scale. So like the thing that we kind of like discussed today is our proof of stake blockchain of like doing transactions on our network and eventually putting them on Ethereum if you choose to do so. But there are other solutions that we have, like there's one that recently came out called Polygon Edge that actually allows you to create your own EVM compatible blockchain, kind of like bootstrapped using some of the Polygon features. And, depending on your use case, that might be something more for like an enterprise level application, a larger application that has like tons and tons of users. that needs like dedicated block space or something like that. So we have like these different types of solutions for different use cases. How do you bridge from Polygon to other layer 1 blockchains like Ethereum and so on? So you can go onto the Polygon Web3 wallet. Let me grab that. But this will showcase like an easy way to like bridge assets. And then if you want to like do it more programmatically, you can definitely run through the documentation to add that to your dApp. So will Polygon's efficiency improve further after you guys are asking like the hard hitting questions. So will Polygon's efficiency improve further after the launch of the Beacon chain? If you're looking at like, I guess the proof of stake chain, like interacting with the two different chains will largely like on the surface probably not really change all too much. The initial launch of I guess the merge or everything that's like, coming up soon is not really going to lower transaction fees or anything like that. It's more for like moving over to a proof of stake mechanism so that Ethereum itself also becomes more environmentally friendly and uses like a lot less energy. So a lot of the, so while that may be one less reason of like why you would use Polygon over Ethereum, you're still going to have like, transaction fees and things like that. And like speed still be a factor. But there are, of course, going to be continued improvements on top of Ethereum. What other layer 1 blockchain can Polygon work with? It's really mainly in the Ethereum world. I don't, I can't really say it's like what other layer 1s it can like fully work with, but I'm sure there are folks who are building bridges, for other chains as well. In your opinion, do you think Polygon fees will still be cheaper when the merge happens? Absolutely, yes. The merge is not going to lower transaction fees whatsoever. That is a popular misconception. It is only lowering energy costs, not transaction fees. So it will still cost the same or similar amount of gas to do things on Ethereum post-merge. There are improvements in the future are called like sharding and other techniques that will be working towards lowering fees, but post-merge, you'll still have to pay large fees on Ethereum network. Is Goerli a valid Polygon testnet since it's found in, yes, it is also a good testnet. I would probably just like recommend using Mumbai as it's like the most popular testnet on our side of things, just like it has like most of the support.
Okay, now that you've asked a lot of questions, I can see Rahat wiping off the sweat off his face from questions. No, I think we'll call it there. There's still a big week of workshops coming up. Tomorrow we've got an Unstoppable Domain workshop. Then we've got NFTs on Thursday with Rahat again. And then next week we have DAOs on Polygon. So there's a lot of good stuff coming up. So thank you so much. If you haven't registered, please make sure you go register. Please give Rahat a follow on Twitter, boost his followers, and just a little thank you as well. We really appreciate you being here, Rahat. Thank you so much. And thank you all to the hackers that were here. Really, really good. Just a reminder, please refrain from using any kind of bad language. We will kick you out and we don't want to have to ban you from future Encode events. But yeah, other than that, thank you so much and enjoy the rest of your day.